All right, guys, for the next few videos, I'm going to be working through full examples of a hypothesis test. So I've got my formula sheet and my calculator ready so that I can work on these different steps. So example one, in 2005, 21% of the US population smoked cigarettes. You think this is no longer accurate and you wish to test this claim. You collect a random sample of 300 individuals and you find that 46 of them smoke. Conduct a test of hypothesis to test that the proportion is different than 21%. So right off the bat, as soon as I am seeing percents in here, it doesn't say anything about means or averages, it talks about percents. So what that tells me is that this is a one prop z test, which means later on we're going to use a one prop z interval. Okay, so our null and alternative hypothesis. So we always start our test out with this H sub O, H sub A. Because it is proportions, we're going to use P here because somebody is making a claim about the population proportion. And the original claim is that 21% of the US population smokes cigarettes. So the original claim is that the population proportion is 0.21. Now, always in the problem, there will be some sort of language that helps you decide what you're going to do for your alternative hypothesis. So if you remember, for your alternative, you now get the option of less than, greater than, or not equal to. So going back through here, I am looking for specific language that lets me determine, is there reason to believe, are they claiming that they think it's less or greater? And in fact, in this one, they don't. All they have is this keyword here that it's different than 21%. So, what that tells me, I don't know specifically whether it's less or more. I just think it's different, which is my indication that I'm going to use not equal. And we always use the same number here. So, alternative hypothesis should still use P and 0.21. The only difference is we are now switching from equal to something other than equal. So they're claiming that the original or the population proportion is 0.21. We say no, we think it's different. So your level of significance is alpha, and unless you are told otherwise, it's going to be 0.05. So they didn't say anywhere in the problem, what level to use. So we're just assuming 0.5. So now what I'm going to do is I'm going to start finding my critical value and test statistic. So here's my formula sheet for critical value. Because this is not equal, that makes it a two-tail test. And maybe I should add that to this formula sheet. Left is less than, right is greater than, two-tail is not equal to. So that means I'm going to have two critical values, one on each side. So according to this, I have to do inverse norm. I'm going to do my alpha value divided by 2, 0 and 1. And I'm going to use plus or minus. So I have two critical values. I have negative 1.96 and positive 1.96. So these critical values, these are what cut this off. Anything outside of that, anything more than 1.96 standard deviations above or below the mean is unusual and suspect, and we will then maybe get to reject the null. So we've got our critical values. So now what we're going to do is we're going to find our test statistic. So here is our formula for test statistic. So let me just copy this down on here. So it's p hat minus p divided by the square root of p times 1 minus p over n. Okay, so some of the things that we already know. There's really only three values that we need. We need p, which we know. P is the claim for the hypothesis, so 0.21. P hat, hopefully you remember, is the sample proportion. So when I go up here, I'm seeing that they found in their sample 46 out of 300. So my p hat value is 46 out of 300. So that is 0.153. Okay. And then 300 would also be my N. That's my total number of people that I have. So this is what I've got going on for my variables. So I'm going to plug everything in. So 0.153 minus 0.21 over 0.21, 1 minus 0.21 divided by 300. So just a second here. Okay, so doing my calculation for this, I got negative 2.43, and it should make sense that it's negative because as you can see, our sample proportion was less than the claim, less than the population claim. So in terms of z-scores, that gives us a negative. So negative 2.42 would be sufficient. So now what we want to do, these are our critical values. And then my test statistic falls somewhere out here beyond that 1.96. So it falls into the reject region. So this step right here tells me I get to reject the null hypothesis. Now, what we want to see is we want to see that everything after this supports that same decision. So now what I want to do is I want to find my p-value. So going to my formula, two-tail test. So we're using normal CDF. I'm going to use the absolute value, so 2.42 to infinity. Then because it's a two-tail test, I have to multiply it by 2. So I get a p-value of 0.016. And I'll write down what I put in here too. Okay, so I have a p-value of 0.016. So now it comes time to make a decision. So this fell in the reject region, so that tells us reject the null. My p-value, and I need to be more careful about that. I'm sorry. I need you guys to be careful about that too. We want to write it out as p-value, not just p, because as you see, p is a different variable that gets used. So my p-value is 0.016, and what that means is it is less than alpha. So that also means we get to reject the null. So that means we're saying, okay, based on our evidence, we do not think your original claim of 21% is accurate anymore. So now what we're going to do is we're going to do our confidence interval. So we've already learned how to do the confidence interval in the calculator. You're going to stat, test, and this is a 1 prop z interval. So it uses x and n. That was our 46 and our 300. 95% confidence, and remember we use 95 because it goes hand in hand with our alpha value. So if alpha is 5%, confidence has to be 95%. So here is our confidence interval. So I got 0.11 to 0.19. Okay, so we're 95% confident that the true proportion of the U.S. population who smokes is actually between 0.11 and 0.19. So that's from 11% to 19%, which is different than that claim of 21. So here's what I mean by all the things have to support each other. This step said reject the null. This step said reject the null. And this step also says to reject the null because your null hypothesis of 21 is not in the interval. So we're 95% confident that it can't be 21 because it is not contained in our interval. So that's what I mean when I say that all of these things should support one another. Okay, so that's our first full example of a one-prop z-test.